Hello everyone, welcome back to Sushiverse, the place where learning gets simpler and smarter. Today we are diving into one of the most human-like algorithm in machine learning, which is nothing but the decision tree. It's an algorithm that thinks just like we do. It asks questions, based on the answers it narrows down to a decision. So if you have ever wondered how a decision tree decides what question to ask first, so stick with me, you're going to love this video. Let's start. So what is a decision tree? Imagine you walk into a store to buy a laptop. You don't just pick one randomly. You might ask yourself, like, do I have a high income? Like, yes or no? And do I care about the specific brand? Again, it will be divided into like yes or no. And the next thing, am I a student or a working professional? Because student will be having different requirements and working professionals will be having different requirements. So each question helps you narrow down your choices. That's exactly how a decision tree works. And also, decision tree is a supervised machine learning algorithm which is used for both for classification and regression tasks. But in this particular video, we will be discussing about the classification tasks. Before we start building, let's quickly define three important parts of the tree. The first one is a root node, and the next is a decision node, and the last one is a leaf node. So, root node is nothing but the first question or split based on the feature with the highest information gain. And while coming to the decision node, these are internal nodes that split the data further. And while coming to the leaf node, this is the final decision where no more splits are needed. Let's understand this tree-like structure with a basic example. I just took like this is the root node, like whether the person cracked the gate exam or not. So again, this will act as like yes or no. So if yes, they will be applying for the colleges, like for IIT colleges through COPE portal. And if not, they will prepare again for the gate exam. So here you can see this node will not have again further splits. So this is acting as a leaf node. And while coming to here, like if they get the IITs, so they will join this particular colleges. If not, again they will apply for NITs through CCMT portal. So this is a basic example. And just keep in your mind, like in this particular video, I just took the color coding. Like orange will act as root node, and whereas green will act as decision node, and the purple is acting as a leaf node. Okay. And also, before solving the problems, you need to understand about the two important terms. One is the entropy and the other one is information gain. You need to understand the formulas of this. Entropy S is equals to minus of probability of positive class into log of probability of positive class minus probability of negative class into log of probability of negative class. It is something like in your classification tasks, like if you just consider like few students will be passing the exam and few will be failing the exam, correct? So if you just assume like 2 students have failed in the exam and 5 students have passed in the exam, so here entropy you will be taking as minus of probability of positive class, which means 5 members passed divided by overall things, overall observations, and log of 5 by 7 minus of, now will be negative class, 2 by 7 log of 2 by 7. Okay, but please make sure this is like log base 2. Again, if you take some other base, you'll be having some other values which will be not correct. So this is the formula of the entropy. Now information gain is equals to entropy, this is the overall entropy, minus summation of mod of SV divided by mod S into entropy of SV. Which means, for example, just consider one feature, like you're having a feature which is like student, like there are 2 students maybe, and professionals, maybe you're having 3 professionals. Just consider for the example. So here when you're considering this, like for the information gain, so here it will be something like for students, it will be 2 by 5 into entropy of student. And next will be something like plus 3 divided by 5 into entropy of professionals. Okay, so this is entirely summation and you'll be having negation here. I will explain you like how to calculate this entropy and gain for the particular data set. So first understand the data set. Yeah, so this is my data set. I just took the ID like 1 to 8 IDs and the type, like whether the person is a student or professional, and the income level, which is like low, high, medium, as well as the brand preference if the person is having specific brand in his mind for the particular laptop, like again yes or no. And finally, this is the classification, which is like whether the person will buy the laptop, like yes or no. So the first step is to calculate the entropy. So here if you see entropy, this is the overall entropy. This will be calculated with the classification column, which is like no, yes, like the final column, final classification. So if you see here, I'm having 1 yes, 2, 3, 4, 5, total 5 yes IDs, as well as no as 3. So if you remember the entropy formula, which is nothing but minus of probability of positive class, which is nothing but 5 divided by 8, which by I wrote 8, it's nothing but, you know, the probability, right? Like the number of favorable observations divided by total number of observations. So if you see here, I'm having total 8 observations. Out of those, 5 are yes and 3 are no. So minus of 5 by 8 logarithmic of 5 by 8 minus 3 by 8 log of 3 by 8. So after calculating these things, I got 0.954. Now the next step will be we need to split based on each feature, which means we will be splitting based on type, income level and brand preference, which means we will be calculating the information gain for each of the features available in the data. So if you see here, I'm splitting on the type. You can see I'm having ID1, ID3, ID5 and ID8 as student. You can see that. So these are the particular IDs as student. And the next thing, whether they bought the laptop or not. You can see here the first one, like with the person with the ID1 as no, ID3 as yes and ID5 as yes and ID8 also as yes. So that is why I wrote, so whether the person bought or not, like no, S, like for each of the ID. Okay, now we will be calculating the entropy of these things. If you see here, probability of positive class is nothing but 3 by 4 and probability of negative class is nothing but 1 by 4. So minus of 1 by 4 log of 1 by 4 minus 3 by 4 into log of 3 by 4. After calculating these things, I got the value as 0.811 only for the entropy of student. Okay, now I need to calculate even for professionals also. If you see like the IDs which are professional, like 2, 4, 6 and 7. If you also see like yes, no, yes and no. So there are like 2 yes values and 2 no values. You can see here like 2 yes values and 2 no values. Now entropy of professional is nothing but the probability of positive class is nothing but 2 by 4. So minus 2 by 4 log 2 by 4, and again the no is also similar, which is nothing but 2 by 4. 2 by 4 into log of 2 by 4. I got this value as 1. Okay, so after that we need to calculate the information gain for this particular feature. If you see the formula of information gain, the first will be the overall entropy, which is nothing but 0.954 is my overall entropy. So 0.954 minus of, now we need to understand here how many professionals are there and how many students are there. If you see here, I'm having 4 students as well as 4 professionals. But you need to understand this. Here in the formula we are having something like this, mod of SV divided by mod of S. So which means the number of persons in the type label are students divided by overall, which means like the how many how many people are student here, like 4 people are student, but overall I'm having the combination of student plus professional is 8. So which is nothing but 4 by 8. 4 by 8 into entropy of student. Now next time I'll consider it for professional. Here you can see like my professionals are like 4 professionals but divided by 8, because student plus professional is nothing but 8, and I'll having entropy of professional. So now information gain is equals to 0.954 minus 0.905. After calculating these things, I got 0.905. So now the information gain of this particular feature, which means of this type feature, is 0.049. Now similarly we will be calculating same for the income level also. Some people get confused. Just listen once again like how we are calculating the individual entropy first and how we are calculating the information gain. So now if we see this income level, you can see here income level which is nothing but low, high, medium, correct? Now let's get into here. We will be calculating for low, medium and high. Just observe the IDs which are having low and the next IDs which are having medium and the IDs which are having high. And also this is a classification, like the person with ID 1 haven't bought the laptop, but the person with ID 5 bought the laptop and the person with ID 7 haven't bought the laptop. The first thing is to calculate the entropy, which is nothing but probability of positive class. So here I'm having yes. So minus of 1 divided by total observations are 3. 3 and log to the base 2 of 1 by 3 minus rest of the no classification. 2 divided by overall 3 log of 2 divided by 3, which is nothing but 0.918. The next one is medium. So here the IDs 3 and 4 are type medium and the classification for ID 3 is yes and the classification for ID 4 is no. Here entropy is nothing but again probability of positive class, which is nothing but 1 divided by overall classifications yes no, like 2 are there, log of 1 by 2 minus again no, 1 divided by 2 log of 2 into 1 by 2, which is nothing but 1. And if you want to split for the high, so here you can see for the ID 2 and the ID 6 and ID 8 all are yes values. So you can see minus 3 by 3 into log 3 by 3, which is nothing but log 1 is 0, so you'll be getting 0. Just remember in the mind, if you always have the same values like no, no, or like how many times even if you're having no, your entropy will be 0. And also if you're having no, no or yes, yes like equal times, then your entropy will be 1. So now we got the individual entropies like for the low, medium as well as high. Now it's time to calculate the information gain. You already know the overall entropy as 0.954. Now for this information gain, you know like how many values are there as low? There are like 3 values. 3 divided by overall values are 8 into entropy of low class, which is 0.918. Now next we'll go for the medium class, which is nothing but I'm having 2 observations of medium, but the overall are 8 observations. So 2 divided by 8 into entropy, which is nothing but 1. Now again, for high I'm having 3 observations as high, but my overall observations are 8. So 3 divided by 8 into entropy of high, which is nothing but 0. So if you calculate this, I got 0.36 as my information gain here. Now again we are having another feature which is nothing but the brand preference like yes or no. So I'm having these IDs like ID 2, ID 3, ID 5, 7, 8 as yes classification. And for no I'm having 1, 4 and 6. So this is the overall classification, like whether the person with ID 2 have bought the laptop and the person with ID 3 have bought the laptop. Similarly for person 7 haven't bought the laptop. So this is the classification. Don't confuse here. So this is the feature for the brand preference and this is the overall classification. So I guess by now you understand how to calculate the entropy, like the probability of positive class into log of probability of positive class. Again minus of probability of negative class log of probability of negative class. That is how I got here 0.722. Similarly here minus of probability of positive class into log minus of probability of negative class into log, I got 0.918. So if you see here, now I have S observations as 5 and no observations as 3. Oh, so if I want to calculate information gain, overall entropy minus 5 observations divided by 8 into entropy of S classification here, and plus here which is nothing but 3 observations, 3 divided by 8 into 0.918. So now I got information gain as 0.159. So I have calculated the information gain for all the features which are available in our dataset. I just made a note of this. For the feature type, like either student or professional, I'm having 0.049. For the income level, I'm having 0.36. And for the brand preference, I'm having 0.159. So if you consider out of these three, 0.36 is the highest value. Correct? So that is why this is my level 1 decision tree, which is nothing but it will start with the income level as a root node because of the highest information gain. So once if I get the income level here, so I'm having different things like low, medium or high. So let's understand again once from the data set. Yeah. So here root node is nothing but the income level. You can see like low I'm having, high I'm having, medium I'm having. So now if you see here low, low and low. And if you see my classification, no, yes, no. Here I can't directly take into consideration like the income level low will be always yes or will always be no, like how the classification happens. So just keep it aside. Now again see for medium. Medium, one is yes and one is no. Here also I can't conclude the decision now itself. But if you see this high, here high and high. If you see here for high, every time I am having only yes classification. So now the income level, which is of type high, will have the further leaf node only as yes. So you can see for the level 1 decision tree here. So for the high, it is only yes. And if you remember the color coding, orange is the root node, green is the decision node, and purple is the leaf node. So this is the level 1. Now you might be thinking like what should be for low, like what do we have some yes or no directly, or do we will have some brand preference, or do we will have some other things. Even for medium also we are confused. Now let's only consider the income level as low. Okay, so for the ID 1, 5, 7 I'm having income level as low, correct? So you can see here now I'll be calculating again overall entropy for this small data set where the income level is low. Okay, so if you see here I'm having 2 no's and 1 yes. So my overall entropy will be minus of probability of positive class divided by total number of observations into log minus of probability of negative class classification into log of this. So my overall entropy is 0.918. Now again we will be calculating the individual entropies like individual feature entropies, and again we'll calculate the information gain. So let's see how it will go. Now if you see split by type will happen and split by brand preference will happen. So if I go by split by type, I'm having ID 1 and ID 5 as student and professional as 7 like with ID 7. So first step is to calculate the entropy. So by this time I think you guys understand like how to calculate the overall entropy and how to calculate the entropy of the specific classification things and the information gain. Okay, so now if I go split by type, so my overall information gain is 0.251. And while coming to the split by band preference like yes or no, so this is my entropy I just wrote directly because I'm having equal yes or no, so my entropy will be 1, and here there is only one no classification, so my entropy will be 0. So here also information gain. So like if you understand from this particular data set, here the first one is income level 0.918, and now I also minus took the brand preference will be 0.251. Here if you see the information gain 0.251 and here also the information gain is 0.251. So if you get any time like the same values of the information gain, so you can take any one of the feature. But here I took as a brand preference. So the first root node will be income level, which is like low, medium and high. For high, I already knew my leaf node is yes. But for this low, I'm just considering this brand preference. Okay, so if you understand from this data, here the income level is low for all these things, correct? And the brand preference is between no and yes. So if you think of it like my further tree will be something like yes or no kind of after seeing this brand preference. So now if you just consider like only no because you are only having this one observation. So if you see here, I'm having income level as low, brand preference as no, and that no is nothing but only student. There is no confusion between the professional or student like what it will happen, correct? So now if you see at the level 3, I got another leaf node where the brand preference is no, which is nothing but he will be student and they won't buy the laptop. This is for sure. But again now if I have brand preference as yes, now I know that it's okay. So one yes will be for one student and another yes will be for professional. So here my yes again will act as an decision node. So you can go ahead and see yes will be the decision node, and out of this decision you will be thinking of student or professional. Okay, here it is like no, and it is strictly only for student. There is no other classification over this. So this is at level 4. So now we have concluded for the high, for the low. Then what about the medium? Okay, so for medium, just again once let's see the data set in the starting which we took. Yeah. So here you can see I'm having medium over here, and there was a brand preference, yes, no, and to buy a laptop, yes, no, and this type is student or professional. Okay. So now let's see the final decision tree how we got. Yeah. So here you can see for the medium also I took the brand preference, and according to that either yes or no I have classified. If yes, it is particularly the student, and if it is no, it is only for the professional. So here mine is a small data set, but if you are having a large data set with many features, so you'll be calculating the overall entropy in the first step, and then you'll be calculating the entropy like for each individual features, like whether you're having yes classification or no classification, or if it is something like a student or working professional, so depend on the feature, and you'll be calculating that entropy, and finally you will calculate the information gain. So based on the highest value of the information gain, you will be splitting it accordingly. So this is all about this video. If you found this really helpful, please hit that like button, do subscribe and share it with your friends, and also please drop a comment. Thank you.